our discussion for today is about graph of functions. Okay, so take a look at this illustration. Now, as you can see here, we have the xy plane. We have the x-axis that consists the x values here, and the y-axis that consists the y values. Now, we also have y is equal to f of x. Okay, the graph of y is equal to f of x is this one. Okay, so what do we mean by graph? The graph of a function f is the collection of ordered pairs x and f of x such that it is in the domain of f. So for example, we can only say that this is the graph of the function provided that it is the collection of ordered pairs. Yes, it's really a collection of ordered pairs because this point here, for example, -1, there is one corresponding value, which is the y-axis. No, the y value. For example, if x is -1/2, there is a y value that corresponds to -1/2. If x is equal to 0, there is a y value that corresponds to 0 and at this point. And if x is equal to 1, for example, there is a y value that corresponds to the x value, which is 1. And if we connect all the points, then we can create a graph. Therefore, the graph is the collection of ordered pairs. Okay, going back to this illustration, the x here is the directed distance from the y-axis. This is the directed distance. If we look at the y-axis from 0 to this values here to any point in the x-axis, so we have the directed distance from the x-axis. Well, y is equal to f of x is equal to the directed distance from the x-axis, okay? From the directed distance. So it's the height from the x-axis going to any point of the graph. Okay? So from the graph, we can get a lot of information. For example, look at this graph. This is the graph of the function y is equal to f of x. This is a generic graph. Now, if you are asked to find the following, let's say use the graph of the function f to find. The first one is the domain of f. What is the domain of f? Is the set of x's or the set of input values that can make the function defined. Letter B, the function values of f of -1 and f of 2, and letter C, the range of f. So what is the domain of the function given the graph only? The domain of the function is you have to look at the x values. Okay? Now the graph lies on the x values from -1 to what? This is 0, this is -1, -2, -3. So the graph lies on the x values from negative or is continuous on the interval from -1 to 5, right? So meaning this is the domain, the specified domain or specific domain in this case, in this graph. So what would be the domain? The domain is a set of all x's in the closed interval, in the open interval as well as closed, because here it is shaded, meaning the x is equal to -1 is included. So the domain is the set of x such that x is in between and from -1 to 5. So we use to describe the domain, we use the interval notation, meaning from -1 to 5 and 5 is not included. This is the set of input values. For example, if x is 0, then the y value is 3. Okay? If x is, let's say, 2, the y value is -3. And if x is 4, the y value is 0. Okay? If x is 5, y value doesn't exist. That's why we use the hollow part. It's not shaded. Okay? So that is the domain. Next is what is f of negative 1? So look at the graph. When you say f of negative 1, it is the value of the function at x is equal to negative 1. It's the y value if x is negative 1. So look at the graph. If x is negative 1, what's the y value? The y value is 1. That's why f of negative 1 is equal to 1. Or in ordered pair, this is written as negative 1 and 1. What is f of 2? Look at f of 2 here. F of 2, then what is the corresponding y value? It is negative 3. So f of 2 is negative 3. And if we write that one in an ordered pair, so this is written as 2 and negative 3. Okay? So how about if x is 0? If x is 0, the y value or f of 0 is equal to 3. Now, what is the range of f? The range of f is the set of y's. Okay, so look at this graph. The set of y's is from here to this point, right? From the minimum point to the maximum point. So what is the range? The range is negative 3 to 3. Okay. So here we have library of functions, although some of these functions were already discussed in the previous videos when we talked about the domain of the functions. So we will integrate our learning in the previous videos regarding the domain as well as the topic here, which is the graph of the functions. So this is the first function, which is what we call the constant function. This is the graph of the constant function. As you can see, the function is given by f of x is equal to b, where b is a real number or any constant. Now, any observation? Okay. Take note, the domain of the constant function is the set of real numbers, right? Let's say if x is 0, there's a point. If x is 1, if x is 2, if x is 3, up to positive infinity. And if x is negative 1 up to, or negative infinity to here. So the domain is the set of all real numbers, or denoted by BR. What is the range? The range is the set of B, is the set of constant B. Okay? Since it is a set, because the range is a set, is the set of output. Now, in this case, we only have one element in our set, and therefore, this is what we call a singleton set. Okay, because we only have one element in a set, and that is element B. Because for any value of x, let's say x is 1, it has only one y value, which is b. If x is 4, it has only one y value, which is b. Even if our x is negative, if x is negative 1, for example, then the y value is still b. Now, we have also to remember that graph is horizontal line with y-intercept is b. So, in a constant function, the graph is horizontal line with the intercept, with y-intercept, which is b. So, here we have 0 and b. Next is the identity function. Now, the identity function is denoted by f of x equal to x. As you can see, it's linear, okay? Now, f of x is equal to x. Take note that we have here the 3 points, 0, 0, 1, 1, and negative 1, 1. Now, what is the domain? The domain of the identity function is still the set of all real numbers. And the range is still the set of all real numbers. Now, we have to remember that even we can only have 3 ordered pairs or 3 points, then we can have a graph of a function. Okay, note that the line consists all the points for which the x-coordinate is equal to the y-coordinates. Now, as you can see also, if you observe that the identity function, the x-coordinate is equal to the y-coordinate. For example, if x is 1, then the y-coordinate is 1. If x is 0, it is 0, the y-coordinate. Okay, if it is 2, for example, then we expect that the y-coordinate is 2. So we have to take note of that. Square function. This is the graph of the square function. Okay, any observation? Now, by the way, the graph or the function, the square function is given by x squared. This is very familiar. Okay, then the domain of x squared is the set of all real numbers. The set of inputs, the set of all real numbers. However, um, the range of x squared is 0 to positive infinity. Why? Because for any value in the input in the set of inputs, if you input that one, the result is always positive if it's not 0. Okay? For example, since the equation is x squared, so for example, if x is negative 1, then the function value is 1. If x is negative 2, the function value is 4, right? So that's why the range, which is the set of output, is the set of all real numbers, okay, greater than or equal to 0. Or shall we say 0 to positive infinity. Now, we have to remember that the graph of a square function is the graph of a parabola. Cube function. The cube function looks like this. Okay, this one. Then this is given by the equation f of x equal to x cubed. And suppose we have the point 0, 0. So by just substituting the value in our domain, so we can have the value, okay, in the set of the y values or the range. Let's say if x is 0, the y value is 0. If x is 1, the y value is 1. If x is negative 1, so simply substitute negative 1 times negative 1 is positive 1 times negative 1 is negative 1. Okay? So just familiar with this function. Now look at the graph. The graph of the uh, cube function, it has a domain of R, which is the set of all real numbers, and also the range, the set of output is the uh, range. Another function is the square root function. This is given by f of x is equal to the square root of x. Okay. Now, by looking at the graph, it is clearly shows here that the square root function is defined if x is greater than or equal to 0. Okay? We already tackled that one when we discussed about domain. Now, if x is equal to 0, the y value is 0. If x is equal to 1, the y value is 1. If x is equal to 4, the y value is 2. But if x is negative 1, it will become or we can have an imaginary number. So it's no longer a real number. So it's undefined. Okay, so look at this one. So here, the domain, by just looking at the graph, the domain is 0 to positive infinity. While the range, by just looking at the graph also, the range is also 0 to positive infinity. Okay, you consider the minimum point, this one, and the maximum point, it's infinity. Okay, because we can extend that one to positive infinity. Then the cube root function. The cube root function is given by this graph. Okay, as you can see, it's like what? Cube function, but in a different position, right? So this is the graph of a cube root function. Now, by just looking at the graph, what is the domain? The domain is R. How about the range? The range is also R, which is the set of all real numbers. Another one is the absolute value function. This is the graph of the absolute value function. Okay. Now, this is denoted by f of x equal to the absolute value of x. Okay. As you can see, we have 0, 0, x is 1, 1, and x is 2, 2. If x is negative 1, then y is 1. If x is negative 2, then the y value is 2. Okay, if x is negative 3, the y value is 3. Okay, what is the domain of the given function, absolute value function? By just looking at the graph, we can say that the domain is the set of all real numbers, but the range is 0 to positive infinity. Meaning, the absolute value of any number is always positive, and it is 0 if x is 0. Okay, so those are the graph of the basic functions. Here, the basic functions that are very useful when we go to the concept of calculus. So, hope you like this video and do not forget to share the learning that you've got from this video. Thank you so much, and for our next topic, we will be talking about polynomial functions. Thank you once again, and God bless.